What is a crest?
The highest point of a transverse wave.
What is thermal energy?
The sum of the kinetic and elastic energy of the atoms and molecules.
Why do physicists believe that there are particles inside protons and neutrons?
Ernest Rutherford, 1871 to 1937, scattered alpha particles off gold atoms and discovered that the atom was not filled with a uniform positive material. In the same way, scattering of protons at high energies off hydrogen nuclei showed that the proton is not composed of uniform positive material. Rather, it is composed of three much smaller charged particles called quarks. The neutron is also composed of three quarks.
What is a calorie?
Heat, like work, processes that transfer energy, is measured in the joule, a unit named after James Prescott Joule. Although the joule is the international standard for measuring energy, heat flow is often measured in calories. A calorie defines the amount of energy needed to increase 1 gram of water by 1 degree Celsius. The energy required for 1 calorie is 4.186 joules, which is a relatively small amount of energy. Nutritionists also use the term calorie to describe the amount of energy a particular food can provide a person.
When will the United States see its next total solar eclipse?
Although the entire United States will not see the eclipse, it will sweep across the country from Oregon to South Carolina on August 21, 2017. Mark your calendars.
Does the gravitational force also obey Newton's third law? How?
All objects have gravitational fields surrounding them. So, just as the moon has a force exerted on it due to Earth's gravitational field, Earth has a force on it due to the moon's field. As a result, the moon does not orbit around Earth's center. But the moon and Earth orbit around a point roughly 2,900 kilometers from Earth's center. The Sun and other planets also exert gravitational forces on Earth, and Earth does on them. The gravitational fields of the planets, in particular Jupiter, cause the Sun to orbit around a point near its surface. Thus, if an observer on another planetary system studied the motion of the Sun carefully, he or she could determine that planets were orbiting the Sun. This method has been used to detect well over 200 planets. Called exoplanets, or planetary systems and other stars.
What would happen if the table were replaced with a sheet of paper?
The paper might hold small stones. But with a heavy rock it would tear because it could not exert a strong enough force. The heavier the rock, the greater the force the table or floor exerts. In summary, inanimate objects can also exert forces. Forces like these, exerted by humans or tables that touch the object, are called contact forces.
What causes materials to be attracted to magnets?
The ultimate cause of magnetism is electrons. When electrons are in a magnetic field, the forces they experience cause them to move in tiny circles. The circling electrons create their own magnetic fields that give rise to diamagnetism. Electrons are tiny magnets themselves, with north and south poles. In most atoms these magnets are paired so their fields cancel. But, if there are an odd number of electrons, the unpaired electron produces a paramagnet. Oxygen, for example, is paramagnetic. In ferromagnets the unpaired electrons in large groups of atoms interact with each other so that they point in the same direction. This group is called a domain. When a ferromagnet is put in a magnetic field, the domains can line up with their poles facing the same direction, making the material a magnet. In most materials, when the magnetic field is removed, the domains revert to their former random directions and the material is no longer a magnet. For certain alloys, however, the domains remain aligned, resulting in a permanent magnet.
What are the bends?
Nitrogen under normal atmospheric pressure is nearly insoluble in blood. Under pressure, the solubility increases. Thus, as a diver goes deeper, the blood holds more and more nitrogen, which dissolves in the blood during gas exchange in the lungs. As the diver ascends, the pressure decreases, and hence the blood is now supersaturated with nitrogen. The supersaturated nitrogen forms bubbles as it comes out of solution in the blood, or cells. These bubbles collect in veins and arteries. They cause pain, and can rupture cell walls and block the flow of blood to cells, causing injury or even death. The best way to avoid the bends is to rise to the water surface slowly, allowing the liquid pressure from the water to gradually decrease and prevent any physical damage. Most scuba divers use nitrox that contains 35% oxygen and 65% nitrogen. rather than normal air that contains 20% oxygen and 80% nitrogen, to reduce, but not eliminate the possibility of getting the bends.
What were some early ideas about light? Does light travel at a finite speed or is it infinite? Is light emitted by the eye or does it travel to the eye?
These questions were debated for centuries. In ancient Greece, Aristotle, 384 to 322 BCE, argued that light is not a movement. Hero of Alexandria, 10 to 70 CE, said it moves at infinite speed because you can see the stars and sun immediately after you open your eyes. Empedocles, 490 to 430 BCE, said it was something in motion, so it must move at a finite speed. Euclid, 325 to 265 BCE, and Ptolemy, 90 to 168 CE, said that if we are to see something, light must be emitted by the eye. In 1021 Alhazen, Ibn al-Haytham, did experiments that led him to support the argument that light moves from an object into the eye and thus it must travel at a finite speed. At the same time, al-Biruni noted that the speed of light is much faster than the speed of sound. The Turkic astronomer Taki al-Din, 1521 to 1585, also argued that the speed of light was finite, and that its slower speed in denser objects explained refraction. He also developed a theory of color and correctly explained reflection. In the 1600s, the German astronomer Johannes Kepler, 1571 to 1630, and the French philosopher, mathematician, and physicist René Descartes, 1596 to 1650, argued that if the speed of light was not infinite, then the Sun, Moon, and Earth wouldn't be in alignment in a lunar eclipse. Despite this misconception, Kepler, in his 1604 book, The Optical Part of Astronomy, essentially invented the field of optics. He described the inverse square law, the workings of a pinhole camera, and reflection by flat and concave mirrors. He also recognized the influence of the atmosphere on both eclipses and the apparent locations of stars. Willibrord Snellius, 1580 to 1626, discovered the law of refraction, Snell's law, in 1621. Descartes used Snell's law to explain the formation of rainbows shortly thereafter. Christian Huygens, 1629 to 1695, wrote important books on optics and proposed the idea that light was a wave. Isaac Newton's 1642 to 1727, celebrated experiments using a prism to separate white light into its colors, led to Newton's theory of colors published in 1672. He recognized that telescope lenses would cause colored images and invented the reflecting telescope using a concave mirror that would not have this fault. Newton believed that light was made up of very lightweight particles, or corpuscles. In 1665, a publication by Francesco Grimaldi, 1618 to 1663, described how light could be diffracted when passing through thin holes or slits or around boundaries. In 1803, Thomas Young's, 1773 to 1829. Experiments with 1 and 2 slits demonstrated the diffraction and interference of light. Augustin Jean Fresnel, 1788 to 1827, and Siméon Poisson, 1781 to 1827, did both theoretical and experimental work that firmly established the wave theory of light in 1815 and 1818. Isaac Newton used a prism to separate white light into a spectrum, leading to the publication of his findings in his Theory of Colors, 1672.
What is a white light?
The combination of all the colors in the visible spectrum.
But how are they combined?
You can't simply add them, because they have different directions. Go back to the drawing with the arrow. Define north as the direction toward the top of the page. Then add a second arrow 2.0 long in the upward direction. The tails of the two arrows are at the same place, representing the intersection of Main Street and First Avenue. The two arrows are half of a rectangle 1.6 wide and 2.0 high. Draw lines completing the rectangle. The location of the house would be at the upper right-hand corner of the rectangle. Draw a third arrow, with the tail at the intersection of the other two vectors and the heat at the upper right-hand corner. The length of the arrow can be measured on your drawing, or calculated using the Pythagorean theorem, the square of the length, the hypotenuse of a right triangle, is equal to the sum of the squares of the other two sides. In this case, 1.62 plus 2.02 equals 6.56. Then length is the square root of that, or 2.56. So in real life the displacement would have a magnitude of 256 feet.
What is a horsepower, HP?
Unit of power. 1 HP equals 746 W equals 0.746 kilowatts.
Why are those times chosen to calculate velocity and distance fallen?
The first 3 times are chosen so that you can explore your reaction time. Have another person hold a ruler vertically by one end. Place your finger and thumb at the lower end of the ruler, but don't let them touch the ruler. Have the other person drop the ruler and you use your finger and thumb to grab it. Note the distance the ruler has dropped in the time it takes you to react to it being dropped. Compare the distance with the first 3 distances to see if your reaction time is between 0.1 and 0.2 seconds.
What is farsightedness and what can be done to correct it?
Farsightedness, or hyperopia, occurs when the lens of the eye can see objects far away, but cannot focus in on objects at closer range. The cornea and lens of the person with farsightedness cause the image to focus behind the retina, resulting in the images from objects close to the eye to be blurred. In order to correct for farsightedness, a convex lens is used to converge the light rays closer together, permitting the image to fall on the retina. The rigidity in the eye lens that affects older people, making them unable to focus on close objects, is called presbyopia.
What is needed to create a circuit?
A circuit is a circular path through which charge can flow. So, the first requirement is a complete, unbroken conducting path. Second, there must be a source of potential difference, most often a battery. The battery provides the voltage that will produce the current in the circuit. With only a battery and wire connecting the two ends of the battery, the resistance in the circuit will be almost zero, and the amount of current will be very high. This situation is called a short circuit. The wire will become hot enough to burn you. So, for a useful circuit there must be a third element, a device with resistance. This may be a resistor, lamp, motor, etc. In terms of energy, the energy input to the circuit is the chemical energy stored in the battery. When the circuit is complete, the chemical energy becomes electrical energy in the wires. That energy is then converted to thermal energy in the resistor or lamp, or kinetic energy in the motor. The hot resistor or lamp then radiates heat and light into the environment. In our households, the battery is replaced by the electric generating station operated by the utility company. It may use the chemical energy in fossil fuels such as coal, oil, or natural gas to boil water, i.e. produce thermal energy. The steam from the boiling water then turns the generator, converting the energy to rotational kinetic energy. The generator then converts this energy of rotation into the electrical energy that is transmitted to the home. A nuclear power plant uses the nuclear energy in the nucleus of the uranium atoms to heat the water and produce steam. From that point on, the nuclear and fossil fuel power plants are essentially the same.
Who is Roy G? BIV?
The colors of the visible light spectrum, in order from long wavelength to short, can be remembered using the fictitious name Roy G. BIV, which is an acronym for red, orange, yellow, green, blue, indigo, and violet. Each individual color has a particular wavelength. And as the wavelength changes, the color changes to the next color on the spectrum. When combined with the appropriate intensities, these colors form white light.
Do electric eels really use electric fields to capture their prey?
Electric eels do indeed set off electrical pulses to stun and even kill their prey. These eels have special nerve endings bundled together in their tails that can produce 30 volts in small electric eels to 600 volts in larger eels. Besides using the electrical shocks for hunting, the eels produce a constant electrical field for use in navigation and self-defense. Most people do not have to worry about encountering electric eels, however. This variety of eel is native only to the rivers of South America.
What is a superconductor?
Allow electrical current to travel without resistance, and therefore no voltage drop across them or energy loss.
What causes the tides?
The moon's gravitational field exerts a force on the water. Because the field and force depend on distance, the force on the water closest to the moon is strongest. The force on Earth is weaker, and the force on the water on the far side of Earth is smallest. So the water nearest the moon is pulled toward it, and Earth is pulled toward the moon more strongly than the water farthest from the moon. For that reason there is a tidal bulge in the water near the moon, and another on the far side. The bulges, which are the high tides, are not directly under the moon because Earth's rotation drags the water along with it. Because the day is shorter than the lunar month, the high tides actually come about 2 hours before the moon is overhead. Tides also vary greatly with location. The largest tidal variations occur in the Bay of Fundy between the Canadian provinces of Nova Scotia and New Brunswick, where the largest recorded range was 17 meters, or almost 56 feet. There have been many proposals to put a dam across the bay and use the tides to generate electricity. But environmental concerns have blocked construction in that bay. The sun also affects the tides, but much less than the moon. When the sun, Earth, and the moon are aligned, which happens at both full and new moons, the tides are especially high.
How does an airplane wing create lift?
The upward force on an airplane wing caused by the air moving past it is called lift. According to Newton's third law, if the air exerts an upward force on the wing, then the wing must exert a downward force on the air. There are three causes of this downward force. The first is the tilt, or angle of attack of the wing. The tilt deflects the airflow downward. The second is the Bernoulli principle. Because of the shape of the wing, the speed of the air on the top surface of the wing is faster than at the lower surface, and so the pressure is lower. Thus the downward force on the wing is reduced. The third reason is the fact that air sticks to the surface of the wing. The air coming off the upper surface is moving downward. This exerts an additional downward force on the air. The downward forces produce the lift needed to keep the plane airborne.
What is a convex mirror?
Curved outward. The reflected light spreads out rather than converging at a point.
What is carbon dating?
Method of dating objects by measuring relative amounts of radioactive and stable carbon in them.
How are particles accelerated to very high energies?
The two highest energy particle accelerators are the Tevatron at Fermilab, near Chicago, and the Large Hadron Collider, LHC, at CERN, European Organization for Nuclear Research, near Geneva, Switzerland. Both machines accelerate and store protons moving in circular paths in a metallic tube, called the beam line, from which all but minute amounts of air have been evacuated. Beams of particles circulate through the tube in both the clockwise and counterclockwise direction. The beams intersect at several places around the circle so that the particles can collide head-on. Many superconducting magnets bend the paths of the particles into the circle, while other magnets focus the particles into small beams. Electric fields created in high-power vacuum tubes provide the accelerating forces on the particles. In particle accelerators, energies are measured in electron volts, eV. 1 eV is the energy a particle obtains by being accelerated by a 1-volt potential difference. Modern accelerators give particles energies of hundreds of MeV. Mega electron volts, or GeV, billions of electron volts. The Tevatron creates collisions between protons and antiprotons, each giving an energy of almost 1.000 GeV, resulting in an energy of 2 GeV when the two beams collide. In the LHC, both beams are protons. The design energy is 7 GeV in each beam for a total collision energy of 14 GeV.
When tossed in the air, why do hammers wobble end over end?
In earlier chapters we considered only point objects. That is, an object so small that it could be thought of as the tiniest ball. Now we want to expand our considerations to large objects. First, think of a baseball. If a baseball is tossed into the air, the ball follows a smooth parabolic path as described earlier in this book. If, however, a hammer is tossed, its path appears much more complex. Why? All objects are made of atoms. The mass of the object is the sum of the masses of all the atoms. And the force of gravity on each atom is proportional to the mass of that atom. In a baseball, the center may be made of different materials than the surface, but if you ignore the laces, the ball is made up of the same materials regardless what the direction is. That is, the ball is spherically symmetric. The center of gravity in any object is defined as the average location of its weight. Because the mass is distributed evenly throughout a baseball, the center of gravity is located in the center of the ball. However, for an object such as a hammer, with a metal head and a wooden handle, the center of gravity is not directly in the middle. Since more mass is located in the metal head of the hammer, the center of gravity is closer to that point. The laws of physics state that the center of gravity follows a parabolic curve when tossed in the air. Indeed, although the ball and the hammer do not appear to have similar motions, their centers of gravity do. If you watch closely both the center of a baseball and the center of gravity of a hammer, you will see that they both follow parabolic paths when thrown. Because the force of gravity is proportional to the mass, the center of mass is at the same location as the center of gravity.
What is the third law of thermodynamics?
Absolute zero can never be reached.
How does clothing keep us warm?
Our skin is cooled primarily by convection currents in the air. Clothing, especially wool, traps air in small pockets, which reduces or eliminates convection. There can still be conductive cooling through the cloth, but cloth is a good insulator. Home insulation, like styrofoam panels, fiberglass or blown-in cellulose act like clothing in reducing heat transmission by convection. Home insulation is rated by its R value of resistance to energy transfer. R is the inverse of conduction, R equals 1/U. Air pockets within snow and ice function as excellent insulators. Many small mammals build snow dens to keep themselves warm, thereby taking advantage of the insulating properties of the snow. Natives of the Arctic build igloos that also keep the inhabitants warm by reducing loss by convection. Many farmers protect their crops during sub-zero temperatures by spraying water on the crops. And when the water freezes, the plants are insulated by the poor conductive properties of the ice. A tile floor feels cooler than a carpeted floor because tile is a better conductor. That is, mover, of heat. Both materials are actually the same temperature, however. Because tile is a better conductor of heat than carpeting, when your hot foot makes contact with the tile, it heats the top layer and the heat flows quickly through the tile. That makes the tile feel cool to your foot. The carpet is a poorer conductor. The top layer can remain warm while the lower layers stay cool. Much less heat flows from your foot to the floor, so the carpet feels warmer to your foot. This is another example of heat flow by means of conduction.
What is a wheel and axle?
Simple machine. If the radius of the axle is A and the radius of the wheel is W, then if the input force is applied to the wheel, the output force is given by Foutput equals Fput, with A.
What is a voltaic pile?
Or battery in which chemical energy is converted into increased energy of electric charges.
What is active noise cancellation?
Active noise cancellation, or ANC, creates a waveform that is the opposite of the noise so that the noise is cancelled. An ANC headset consists of a 1 or 2 microphones that detect the noise. Electronic circuits that invert the waveform, and a headphone driver. Low-frequency noise is more successfully cancelled than noise at higher frequencies. So passive noise reduction is used to reduce high-frequency noise. As a result, low-frequency noises found in helicopter, jet engine, and muffler noise can be controlled. Using ANC while the high squealing sounds of jet engine noise are more difficult to cancel out. If anti-noise is produced by the headphones, can a person hear other people? Music, etc. sounds that aren't noise. The objective of active noise cancellation is to cancel out the noise waveform by producing anti-noise to interfere with the original noise pattern. Since the result is less noise, other sounds are easier to hear. ANC technology is now available for consumers in headsets that reduce noise and allows for easier communication in loud environments. As a result of this new technology, factory workers and helicopter pilots can communicate more easily, and their amount of stress due to noise pollution should be reduced. Airline passengers can listen to music through ANC headphones, while noise from the airplane is cancelled or reduced.
How is the human voice similar to a wind instrument?
The vibrating source of the human voice are the vocal cords in the throat. Their vibration, at a relatively low frequency of 125 Hz, creates oscillations in the air that fills the throat and mouth. By varying the size and shape of your mouth and position of the tongue, you can change the frequency of the sound as well as the relative amplitude of the harmonics. Try it yourself. Sing a constant pitch. While you vocalize the vowel sounds -a, e, I, o, and u. Note how you change the shape of your mouth and position of the tongue when you go from one vowel sound to another. Frequency. The second harmonic is twice its frequency, etc. Many instruments, especially bells, oscillate in modes that are not whole number multiples of the fundamental frequency. These higher modes are called overtones. Overtones include harmonics, but harmonics do not include overtones. Another confusing point is that the first overtone is not the fundamental. The second harmonic is the first overtone.
Why is a stone easier to lift when it is in water?
Even though the stone sinks because it is denser than water, there is still a buoyant force on it given by Uchtone, waiter, so the stone's weight is reduced. Floating usually refers to a liquid such as water, but can anything float in a gas? Remember that there is a difference in pressure of any fluid between the bottom and top of an object in it given by L bottom equals top plus pGh. Even though the density of a gas, P, is much smaller than that of a liquid, there is still a pressure difference, and therefore a buoyancy. There is another difference between a liquid and a gas. A gas can be compressed, and so the density of the atmosphere decreases as you rise. When a hot air balloon is launched, the air within it is heated and it will rise. As it rises, the density of the air decreases, and so the buoyant force decreases. At some height, the weight of the balloon and basket equals the weight of the air displaced, and the balloon stops rising. The operator of the balloon can go higher by making the gas in the balloon hotter, and thus less dense.
What is a reflecting telescope?
Uses a concave mirror to gather light and focus it. Uses a secondary mirror to direct light to eyepiece.
What is the Heisenberg uncertainty principle?
Heisenberg, together with Max Born and Pascal Jordan, tried a totally different approach using mathematical matrices. As part of their work, Heisenberg developed a principle that demonstrates that in the atomic world our knowledge is limited. The uncertainty principle is written as AX equals H/4n. In words, the uncertainty of a particle's position times the uncertainty in its momentum is never less than Planck's constant divided by 4n. If it has a precise location, then its momentum. And thus its speed, measured at the same time, must be imprecise. Planck's constant is extremely small. And so the uncertainty principle is important only for objects the size of atoms or smaller. The position and momentum of a baseball, for example, can both be precisely known at the same time. The uncertainty principle shows why Bohr's electron orbits cannot exist. If you know the radius of the circle precisely, then it must have some velocity along the radius smearing out its orbit. The uncertainty principle also exists in a form linking energy and time. In this form it says that if an electron is in a state that lasts for only a short time, then its energy is not precisely defined.
How can you convert latitude and longitude to a distance measurement?
A precise conversion is difficult because Earth is not a perfect sphere. Latitude is easier to convert. The circumference of Earth taken over the poles is 24,859.82 miles, which is equivalent to 360 degrees of latitude. Therefore 1 degree is equal to 69 miles. So, the north-south distance between two cities 5 degrees of latitude apart would be 345 miles. Longitude is more complicated. At the equator 360 degrees is Earth's circumference, 901.55 miles. But at the poles it is 0. So the conversion of longitude to distances depends on the latitude. If you use trigonometry to find the distance, you will find that the circumference at a latitude of 0 degrees is the circumference at the equator times the cosine of the angle 0. So, at the latitude 40 degrees, the circumference is 19,076 miles, and 1 degree of longitude is 53 miles. This result is only approximate because Earth is not a perfect sphere. For more accurate conversions, consult a website such as http://www.nhc.noaa.gov/gc-calcs-html.
What is the compressive force?
Force pushing an object together.
Why is your blood pressure taken from your upper arm?
Liquid pressure is dependent on the depth of the fluid. Since blood pressure can't be measured around the heart, and the depth of the fluid must be the same as the heart, doctors and nurses need to find a location at the same depth as the heart. A convenient location at that level is your upper arm. When lying down, however, your blood pressure can be taken just about anywhere. Since most of the blood is at the same vertical level as the heart, the cuff is inflated until no pulse can be heard. It is then slowly lowered. As the pressure falls below the systolic pressure, the pulse can be heard. When it's below the diastolic pressure, the pulse gets weaker. The report 120/70 means that the systolic pressure is 120 torr, the diastolic pressure 70 torr.
What are the limitations on simple machines?
Simple machines must, like everything else, obey the law of conservation of energy. That means that the work done on the machine equals the work the machine does plus the heat the machine puts out because friction has increased its thermal energy. Some machines are highly efficient, meaning input and output work are almost the same, while others put out only a fraction of the work put in. The drawing on page 74 shows a simple machine where the machine has warmed up. That means its thermal energy has increased. It is now hotter than its surroundings, so it transmits heat to its surroundings, which are not shown on this diagram. The output work of the machine is smaller than the work put into it. That means that for the same input force, the output force is reduced by an inefficient machine.
What is a torr?
Measure of pressure using measurement of height of mercury in a glass tube that would create a pressure that balances the pressure of the fluid. Used to be called millimeters of mercury, mmHg.
Why is it easy to tip over some objects?
If you want to tip something over, you'll have to rotate it. As you have seen, rotation means you need to apply a torque. An object sitting on a surface has several forces on it. First, is the gravitational force that acts on its center of gravity. Second, is the upward force of the surface. Third, is friction between the object and the surface that exists only if the surface is on a slant. Now suppose you exert a sideways force near the top of a box. That creates a torque and the box begins to rotate.
What are ultrasonic sounds?
Ultrasonic sounds are those frequencies above human hearing. Frequencies above 20,000 Hz are not heard by people, but are heard by those animals whose hearing is sensitive to ultrasonic frequencies. For example, dolphins use ultrasonic frequencies to communicate. And bats use ultrasonic sounds as a tool for navigation and hunting.
On what does the amplitude of a wave depend?
The amplitude of a rope wave depends on how hard you shake it. For a sound wave, it depends on how much compression the loudspeaker or musical instrument creates. In other words, it depends on the energy the source put into the wave. It does not depend on frequency, wavelength, or velocity.
Why did Chuck Yeager go to such a high altitude to break the sound barrier?
Sound travels approximately 760 miles per hour in the warm, dense air found close to sea level. The cooler and less dense air is, however, the lower the speed of sound. Since air is less dense at higher elevations, physicists and engineers felt it would be easier to break the sound barrier at those elevations. Knowing the temperature and density of the air at 12,192 meters, 40,000 feet, above sea level, scientists determined that the speed of sound would be reduced to only 660 miles per hour. As an added bonus, engineers found that not only was the speed of sound slower at such elevations, but when the air has such low density, the parasitic drag, the drag due to friction, is very low as well. Therefore, to break the sound barrier, Yeager traveled as far up as 13,106 meters. 43,000 feet, above sea level to both reduce the sound barrier and decrease the parasitic drag.
How many nations have nuclear weapons?
The Soviet Union exploded a nuclear device in 1949. It was similar to FAT-Man and was built using information delivered to that country by spies. China, Britain, and France developed nuclear weapons in the 1950s. South Africa had nuclear weapons but abandoned the program. Israel is suspected of having weapons, but has never admitted it. India and Pakistan have both tested nuclear weapons. Iran and North Korea are suspected of developing nuclear weapons. By 1953 there had been 50 above-ground tests of nuclear weapons that created radioactive fallout, contaminating milk and animals. These effects alerted the public to the danger of such testing. The Cold War, however, created an atmosphere in which treaties could not be negotiated. In 1963 a partial test ban treaty was signed, prohibiting tests in the atmosphere, underwater, and in space. In 1968 the Nuclear Non-Proliferation Treaty was signed. Non-nuclear weapon states were prohibited from building or acquiring nuclear weapons. Many nations have signed the treaty, although some major states did not, on the basis that it makes no effort to curb development by states that already have such weapons. In 1996 the Comprehensive Test Ban Treaty was adopted by over two-thirds of the members of the United Nations General Assembly. The United States has signed but rejected ratification in 1999. Nevertheless, 337 facilities around the world monitor compliance with the treaty. They send data to a center in Vienna for analysis and distribution to the states that have signed the treaty.
What alternative analog methods are used?
As was described above, modulating a carrier wave produces additional frequencies above and below the frequency of the carrier. These frequencies are called sidebands. There is identical information in the two sidebands, so many radio services filter out one of the two sidebands, resulting in a single sideband broadcast, or SSB. SSB can work with either AM or FM radios. It has half the bandwidth of a double sideband broadcast. So more radios can use the same part of the spectrum.
What class lever is a can or bottle opener?
Locate the pivot point and compare to the three drawings above. Your forearm is a lever, with the elbow joint being the pivot.
What does a mirror reverse?
If you look in a mirror, you seem to see yourself reversed left to right. Your left eye appears to be your right eye in the mirror. Yet the vertical direction is not reversed. Your chin is still at the bottom of your face.
How can the acceleration be independent of mass? Doesn't a bowling ball fall faster than a soccer ball? Which weighs more, the bowling ball or soccer ball?
You can use your hands to hold first one ball and then the other. You'll notice that you have to exert a much larger upward force to hold the bowling ball at rest. From Newton's first law. If an object is at rest, then the net force on it is zero. That is, the downward force of gravity has the same strength as the upward force of your hands. So, you can conclude that the force of gravity, the weight of the bowling ball, is greater than that of the soccer ball.
How far will it rise?
As some of the wood rises above the level of the water, the volume and the mass, and therefore the weight, of the water displaced will be reduced. When the weight of the wood and the weight of the water displaced are equal, the net force on the wood will be zero and it will no longer move.
How do metal detectors work?
Built into the frame of a metal detector are coils of wire that carry a current. When metal is close to the coils, the magnetic properties of the metal change the current in the coils of wire that is detected by the electronic circuits in the detector. When you walk through a metal detector with metal anywhere on your person, that metal changes the current in the coils in the frame of the detector.
What is acoustics?
Study of the ways musical instruments produce sounds, the design of concert halls, using ultrasound images.
What is a teleportation?
Communicating the state of an atom involving entangled photons.
What is a sphygmomanometer?
Device used to measure blood pressure.
What is the difference between physical and geometrical optics?
Geometrical optics deals specifically with the path that light takes when it encounters mirrors and lenses. Geometrical optics uses the ray model of light in which an arrow represents the direction light travels. The ray model does not consider the wave nature of light. Ray diagrams trace the path that light takes when it reflects and refracts in different media. Reflection occurs when light bounces off a surface, whether it is a piece of paper or a mirror. Shiny metals and very still water make good reflectors, creating images that resemble objects from which the light is coming. Physical optics, on the other hand, is the division of optics that depends on the wave nature of light. It involves polarization, diffraction, interference, and the spectral analysis of light waves.
How much water does a ship need in order to float?
Not a lot of water is needed to keep a ship afloat. Just enough so that it can displace enough water to equal its weight. Therefore, if a ship were to enter a canal that was just a bit larger than the size of the ship's hull, it would float as long as there was a small film of water around the entire hull of the ship.
Why do some athletes go to high elevations to train?
Runners have always trekked to the mountains of Colorado to train in higher elevations because of the lower atmospheric pressure that the mountains provide. Since the air is not as dense as it is at lower elevations, the lungs need to work harder to supply the body with a sufficient amount of oxygen. Many athletes feel that training in such conditions gets their bodies used to lower amounts of oxygen. Therefore, when running in a competition at lower elevations, they can compete quite well because their bodies are used to working hard to get a great deal of oxygen.
What is a transverse wave?
Wave and its energy move perpendicular to the direction of oscillations.
What plays the role of force in rotation?
You have had experiences that illustrate how torque works. Suppose you want to push open a door that rotates about its hinges. You know that the speed with which the door opens depends on how hard you push. It also depends on how far from the hinges you push. The farther the faster. It also depends on the angle at which you push. Pushing at a right angle to the door is much more effective than pushing at a smaller or larger angle. If you push at a right angle, then torque equals the force times the distance from the axis of rotation. With nothing to technically push against in space, it seems odd that rockets could accelerate in space. The explanation is that the force of the combusting rocket fuel itself pushes the rocket, accelerating it forward.
What is a gear?
Toothed wheels that transmit torque between two shafts. The smaller gear in a pair is called a pinion and the larger one a gear.
How is nuclear fission used peacefully?
Nuclear reactors produce electric power. The energy from uranium fission heats water that circulates through the reactor. The heated water produces steam that turns turbines connected to generators. As is the case with all electric power plants, only about 1/3 of the energy produced by the reactor is converted into electrical energy. The remaining energy heats local rivers, lakes, or the atmosphere. In the United States there are 104 reactors that provide about 20% of the electricity used by our country.
What is the difference between laminar and turbulent flow?
The film of fluid that touches the container does not move because of friction with the container's surface. But the fluid in the middle of the stream does. In laminar flow the transition from not moving to moving at full speed is continuous. Each thin film of water moves slightly faster than the one closer to the surface. In turbulent flow this transition from not moving to full speed motion occurs suddenly. And the water moves in tiny circles in this region. Laminar flow has more friction than turbulent. A baseball, for example, has more drag in the laminar flow region.
Does Benjamin Franklin's definition of positive and negative agree with today's understanding of charge?
Franklin decided that sparks given off by an object charged by a glass rod, vitreous electricity, looked more like fluid leaking out than did the sparks from an object charged by a rubber rod, resinous electricity. Thus he decided that glass had an excess of electrical fluid. Today we know that electric charge is mostly carried by electrons. Electrons are charged the same way that rubber or plastic is, negatively. Thus we say that they have a negative charge, because they are transferred much more easily than are the more massive, positively charged nuclei. When there is an excess of electrons, the object is negatively charged. When there is a lack of electrons, it is positively charged. So even though Franklin made the wrong choice, we still follow his convention.
If you now let go, will the box continue to roll or will it go backwards?
It depends on the relative locations of the center of gravity and the force of the surface as seen in the illustration above. If the center of gravity is above the bottom of the box, then the box will return to its upright position. If the center is directly above the corner of the box, then the box won't rotate at all. If the center is outside the bottom of the box, then it will tip over.
How large is the gravitational field at that altitude?
Its distance from Earth's center is about 6.7 x 106 m, so g equals 8.9 n/kg. That's not much different than at Earth's surface. The Moon is 384 x 106 m from the center of Earth. At that distance g equals 0.0027 n/kg. So the force of Earth's gravity on the same kilogram of meat would be only 0.003 of a Newton.
What is inertia?
Inertia is the property of matter by which it resists acceleration. That is, an object that has inertia will remain at rest or will move in a uniform motion in a straight line unless acted on by an external force. In this simple pendulum game called Newton's cradle, lifting one hanging ball and allowing it to drop and hit the second ball exerts a force on the next ball. The force on the ball at the other end causes it to swing out and back, according to Newton's laws.
What is entanglement?
Consider what happens when a positron and electron annihilate. Two gammas, high-energy photons, are produced that go off in opposite directions, 180 degrees apart. They can be detected many meters from their source and have opposite spins. But which gamma has which spin is a random choice. That is, for each gamma there is a 50/50th chance that it will be in a particular direction. Suppose you find that the spin of one gamma is pointing up. But, the moment you detect the spin of that gamma, the spin of the other gamma must be pointing down. The result of one measurement determines the results of the other. The two detectors would measure the spins of their gammas at the same time. So there is no way that one gamma could communicate with the other gamma. Physicists say that the spins of the two photons are entangled and that the spin state of each photon is the superposition of the two possible spin directions. When the spin is measured, the wave function collapses and gives a definitive result. Albert Einstein, 1879 to 1955, called results like this spooky action at a distance. Others have called it quantum weirdness. Similar results can be obtained with atoms or ions, in which case the photons are light quanta and may be transported through space, or the air, or by optical fibers. For example, if an atom is excited by the absorption of a photon, it can emit two photons that are entangled the same way the gammas are in the example above.
What are cathode rays?
Electron beam in an evacuated glass tube.
What is polarized light?
Light is an electromagnetic wave that consists of an oscillating electric field and an oscillating magnetic field. The two fields are perpendicular to each other. In most cases, the direction of the electric field has no preferred direction because different parts of the source produce light with electric fields in different directions. Such light is unpolarized. Some sources, however, like laser pointers, emit light whose electric field is always in one direction. Such light is called polarized.
What is the difference between a red shift and a blue shift?
The visible color spectrum ranges from the low-frequency red, orange, and yellow, to the higher frequency green, blue, indigo, and violet. Astronomers observing the planets, stars, and galaxies use the Doppler effect to measure the velocity at which objects are moving, rotating, or revolving. The faster the object is moving, the more the frequency is shifted. Most galaxies are moving away from us and their light is redshifted. In general, the further away, the greater the redshift. Recently, astronomers have detected more than 400 planets revolving about other stars using the Doppler effect. The gravitational force of the planet on the star causes the planet and star each to circle around a common point. Usually close to, but not in the center of, the star. As a result, the star wobbles with the same period as the orbital period of the planet. The effect is truly tiny. Jupiter causes the Sun to wobble in a circle with a speed of 12 meters per second. By measuring the Doppler effect in the light from the star, they can find its velocity and how it changes over time. With that information they can determine the period, distance from the star, and mass of the planet. Most discoveries have been of extremely massive planets. But recently a planet with a mass only a few times that of Earth was detected. It is close to a dim reddish star and the temperature of its surface is estimated to be tens of degrees below the freezing point of water. If the planet has greenhouse warming, it might be able to sustain life.